Hi everyone, I'm Toby. Today we are going to talk about scalars. A scalar has only magnitude and no direction. Temperature is a scalar, pressure is a scalar, speed scalar, distance, work, flux, and any values without directions are scalars. A vector, however, has both magnitude and direction. We can use an arrow to represent a vector. So on the right side, for example, we have vector A, and we also use an arrow to represent vector A. The length of the arrow represents its magnitude, and the direction where the arrow points to represents its direction. We can use an arrow on the top of a variable to indicate that this variable is a vector. For example, we have R with an arrow on the top, so it means that R is a vector. A with an arrow on the top represents A is a vector, and B with an arrow on the top represents B is a vector. Displacement, velocity, acceleration, force, momentum, these variables are all vectors. So let's talk about unit vector. It's really important. A unit vector has magnitude of 1. The unit is a fancy name for magnitude of 1. There are four typical unit vectors. I hat is equal to vector x over the magnitude of vector x. It has magnitude of 1 and pointing to positive x direction. Same for j hat. It's y over y and has magnitude of 1 pointing to positive y direction. K hat pointing to positive z direction. And r hat is a little bit different. It's the same thing. It represents a unit vector with magnitude of 1 that point away from a certain point. That point can be the origin of the coordinates. A vector A can be represented by 3 kinds of component forms because we can break up a vector into different components. In 3-dimensional space, we typically break up a vector into 3 components. We have x component AX, y component AY, and z component AZ. So this form is called unit vector form because we have all unit vector I hat, j hat, and k hat. What we do is firstly we find the magnitude of all components, and then we multiply each magnitude with its corresponded unit vector. So AX multiplied with I hat indicates the vector AX, and AY multiplied with j hat indicates the vector AY, which is the y component of vector A. AZ is the magnitude of vector AZ, and times k hat is just equal to the magnitude of AZ. Magnitude of vector AZ. And because remember, I hat, j hat, and k hat has only magnitude of 1, so it just tells you the direction, and it doesn't affect the magnitude. We can also use use brackets to represent a vector A, or we can use a matrix. That's the most fancy way, I think. Fanciest the way I think. So it's my favorite way to represent a vector. On 2-dimensional plane, we can simply break up a vector into 2 components, a x component and y component. It's really easy to calculate the magnitude of each component by using trig functions. If we connect the tip of A and AX and AY and the tip of A, we can figure out that it should be a right angle. This is also a right angle, so which means we form two right triangles. Using trig functions, we know that ax over a is equal to adjacent over hypotenuse is cosine theta. So ax is just equal to a times cosine theta. Same for ay. Ay over a is sine theta. So ay is equal to a times sine theta. Because we form two right triangles, we can simply use Pythagorean theorem to find the magnitude of a. Ax squared plus ay squared. If you had z, you can plus az squared. That's all equal to a squared. Now let's talk about vector addition. So before we do vector addition, we need to break up vectors up into components, especially for those vectors that are not on the same direction. For example, vector a plus vector b is also equal to vector b plus vector a. Is equal to ax plus bx times I hat plus ay plus by, sorry, ax plus bx, sorry, it's not times. Ay plus by times j hat plus az plus bz, the sum of az plus bz times k hat. Vector subtraction a minus b is also very easy. It's just same as a plus minus b, a plus negative b. So it's equal to ax minus bx times I hat plus ay minus by times j hat and az minus bz times k hat. So on a diagram, we can use arrows to represent vectors. The first arrow represents A and the second arrow represents B. To do A plus B, we need to put the tail of the B on the tip of vector A. And then we draw an arrow from the tail of A to the tip of B. That is simply A plus B. We can also imagine that, well, you work to the northeast by the magnitude of A, and then you work on the direction that B points to with the distance of B. So that distance is simply the magnitude of vector B. It's just B. And the displacement, we'll talk about displacement later, from your original point to your final destination, it's just A plus B. We have mentioned that B plus A is same as A plus B. So let's simply draw that on the diagram. Okay, so we know if we put B before A, this is just B. We start at this point to this point. This is the ending point. So it's B plus A is also equal to A plus B. We form a parallelogram. These two lines are parallel and has the same direction. It has the same magnitude and direction. So A plus B is equal to B plus A. When we do vector subtraction, we need to reverse the direction of vector B. It has same magnitude but exactly opposite direction, so B becomes negative B. A plus negative B is just A minus B. We draw the arrow from the tail of A to the tip of negative B, we get A minus B. Vector multiplication becomes a little bit complicated, but it's not too hard. Dot product, also called scalar product, because it results in a scalar. A dotted with B is just equal to ax times bx plus ay times by plus az times bz. You figure out that there are no unit vectors here, so this value is actually a scalar. A dotted with B is also equal to A times magnitude of A times the magnitude of B times cosine theta. And cosine theta, if we draw these two arrows, A and B, theta is just the angle between A and B. A dotted with B is also equal to B dotted with A. This is called because dot product, this operation is commutative. The cross product is also called vector product. It becomes a little bit complex, but you can still find some pattern in that. So let me tell you how to evaluate a cross product. Before calculating a cross product, we need to know how to calculate 2 by 2, the determinant of a 2 by 2 matrix. It's 2 by 2 matrix because we have 1 and 2 column, 1 and 2 rows. So rows times column is 2 times 2, so 2 times 2, 2 by 2 matrix. Determinant of a 2 by 2 matrix is equal to A times D minus B times C. Okay, now, because we are in 3 dimensions, so typically we evaluate a 3 by 3 matrix here. So A cross with B is just equal to a 3 by 3 matrix formed by 3 unit vectors and 3 components of each vector. So let's calculate the cross product, the determinant of this the 3 by 3 matrix. So we use pattern plus minus plus pattern first. So for plus, so the first one is plus for I hat. So we put plus sign in here, and then we cross out all values that on the same row and all values on the same column. And as you can see, we form a 2 by 2 matrix here. So we put this matrix here. And then we multiply that by I hat. Okay, so same for J hat. We cross out all values on the same row and all values on the same column. We have 4 values left, forming a 2 by 2 matrix. So it's minus AX, AZ, BX, BZ matrix times J hat. For K hat, same thing. Cross out all values. We need to cross out all values on the same row and all values on the same column. We have 2 by 2 matrix here, so we put it here. And we use this rule to calculate the determinant of 2 by 2 matrix. So we get this expression right here. So that's the cross product of A cross with B. If you only care about the magnitude of this cross product, it's easy. The magnitude of A cross with B is just equal to A times B times sine theta. And sine theta and theta is the angle between 2 vectors. As you can see, theta is just the angle between 2 vectors. If the A times B is this value is positive, this magnitude is positive value, then A cross with B should point up. If you do take the cross product in counterclockwise direction, it should point up. If it's negative, it should point downwards. So therefore, A cross with B is equal to negative B cross A, because if you take the cross product from this direction, then the cross product should point downwards. So A cross with B is equal to B cross with A. Thanks for watching and have a great day.